Going to start a new project today. An acquaintance has a Victorian staircase. There are two of the spindles that are gone. They're long gone. They've been gone for years and years. And going to try to replicate those. I have searched for a while and finally come up with some Douglas fir, which is the material they were made from, on the original staircase. The finish on it is some black cherry antique. I don't know. I'll have to see what I can do to come up with that. And then it's covered with either a real heavy, several coats probably of a shellac or a varnish. And I'll have to try to match that too. But to get started with, I've taken that Douglas fir piece that I found and cut it to length, 28.5 inches long. I'm going to rip out, I don't know, 4, 5, 6 pieces, something like that, so I have plenty to play with, because it's not the best turning wood you've ever seen. It tends to splinter and really make a mess. And I'll make one. I'll get a spindle that's made to the dimensions that I already have, and then I'll take it over to the house and compare it to the staircase. If it's good, then I'll go ahead and make another one that like it. If not, of course, I'll make adjustments and get it just as close to the original as I can. So just put you on time lapse, and I'm going to go through the ripping process and the planing process at least today, and maybe even we'll get started on turning. Now that I have these boards ripped for the spindles, I need to check the moisture. What I use is a Mini Ligno E moisture tester. It has 2 ranges. I'm going to be using the 6 to 20 range, and it's set for that already. The way that it works is the tester has a switch in the center, and when depressed, it activates a current between the 2 pins. When those pins are inserted in the wood, it sends a current between them. The amount of conduction of those pins, of the current between the pins, will determine what the moisture percentage is. This is what they call a group 3 wood. A group 3 wood requires that you make an adjustment to the temperature that's read of about 1 point in the 6 to 20% range. So we'll subtract 1 point for that. Also, the temperature in here is 55 degrees. The tester is set to measure at 68 degrees. So there's a factor that will apply, and best I can tell at this point, because I don't know what the exact measurement is, it'll be somewhere in the range of 1 to 1.5% that we would need to subtract from that number also. So let's go ahead and test and see what kind of moisture we have. So on the outside of the wood, it's showing 12%. Okay? Now, where it was ripped, that's the inside of the wood, and that's showing 14%. I'll grab another piece and we'll see if it confirms those measurements. This one is showing 12% on the outside and between 12 and 14, let's call it 13% on the inside. So if I apply the factors with a negative 2.5%, that means that the inside of the wood is probably running in the 10% range also. That's borderline. Really would like to have it more down around 8. So I'll turn a spindle, take it inside, and see how it reacts. First, I'm going to plane it. Get a little bit of a hailstorm. Inside. The finished size on these spindles needs to be 1 3/8 inches. So I have my caliper set at 1 3/8 inches. They're starting out at right at 1.5 inches. I'll do it in light passes, because I want to take an even amount off of each side to minimize the amount of twist or warp or bow that I'm going to get out of them. So back to the time lapse. The portion of the spindle from here to the end and from here to the end are going to be square. The center portion of it is going to be turned. Okay, so because this wood is very bad about splintering, I'm going to take and router these corners off between the marks. Okay, additionally, when I put it into the lathe, I'm going to take a saw and saw along that edge so I get a nice crisp edge on all 4 sides. So I'm going to go, I've set up with a 3/8 inch corner rounding bit. I'm going to set up and route that now. As you can see, this edge has been rounded. That should keep the splintering at a minimum as I start to turn it. Well, need to sharpen my parting tool. The way this thing is built is it has a flat edge here, and a flat edge here, and then along the side profile, if I can turn it just right, you may be able to see it, that it has a raised rib along each side of the center there. See that? The idea is that that raised rib will make contacts with the side of the kerf as you push the parting tool into the wood. Only the sides will touch. Okay? You have clearance there and there. That way the tool doesn't heat up, doesn't bind up. But in order for it to work correctly, the point has to be exactly in the center of the raised spot. Okay? Right now, I have ground on it a little. I have it off center. As soon as I get it centered, I can polish it. So, that's what we'll work on. Just a little bit more. It's getting close. Okay. So that's with a coarse stone. I need to turn the coarse stone into a fine stone. And you do that with what they call a grading stone. A grading stone will change it from a 120 grit on this side to a 400 grit. So I'll go ahead and do that. Oops. Hear how much less it's taking off now than it was before? Doesn't take much. Still a couple of lines in there, so let me go across it a couple more times. Alright, nice even shine on that surface. Try one more pass, got just one more line left. Oh yeah, I like that. Do the other side. Okay, that's pretty good. Have a wire edge on it. So what I do, take a piece of wood and draw it across there. That'll pull the wire edge off. Now I can set up over here and use a polishing wheel. That'll bring that point out where it'll cut like, well, like a knife. Okay, this is supposed to be a 55-degree angle. It's pretty close. Wanted to check that before I polished it, because if it's off, I'd have to get in there, reset, and regrind. But I think it's pretty close. So, what I do now is take a magic marker here, mark that edge. Okay. Okay. Now I'm going to turn her on and set this so that this distance takes that off. All right, it's from front to rear, it's taking it off. So that's the right depth. Okay, so now I'll lock that in and hone it. Oh yeah. Yep, not a scratch on it. Do the other side. Okay. All right. Let's go see how she cuts. Well, it's pretty apparent this isn't going to work. Tear out on this pine is just too soft. Even using sharp tools, there's no way I'm going to be able to shape this without having to use filler. Okay, now that probably wouldn't be a big deal if I wasn't going to stain it, because I could just fill it and sand it back. But as you can see, the whole piece, and I don't even have it turned all the way, I've just a little more than roughed it, but I can't hold details. See on this bead right here, see the high points right here that are gouged out? There's just no way to salvage this. I'm gonna have to get some hardwood lumber and use it. Won't match what they have in there, but then that house was built long enough that when they used fir, it was old growth fir. Look how wide the growth rings are in this wood. Okay? Don't think there's anything available on today's market, at least around here, that I can use. So I think I'll have to change over to probably an oak and try to find one that has a grain similar to what the other spindles have. And now, here's a word from quality control. As you can see, that didn't work. I came back, rethought the whole project, made several changes, not just to the wood that I used, but also the design of the balusters themselves. I'll give you a little peek at how it ended up, and you can see the progression of steps that I took in coming up with what ultimately was the answer that I used. So stay tuned for part 2, and I'll show you how I dealt with this problem. Thanks for watching.